Good day. This presentation prepared by the Group 3. In this presentation, we will going to perform the following steps on hypothesis testing and answer the following given questions. Page 28, the first problem is warming and ice melt. The average depth of the Hudson Bay is 305 feet. Climatologists were interested in seeing if the effects of warming and ice melt were affecting the water level. 55 measurements over a period of weeks yielded a sample mean of 306.2 feet. The population variance is known to be 3.57. Can it be concluded at the 0.05 level of significance that the average depth has increased? Is there evidence of what caused this to happen? So now, let's perform the following steps in hypothesis testing. The first step is state the hypothesis and identify the claim. In null hypothesis, mu is equal to 305, and in alternative hypothesis, mu is greater than 305. For the second step, find the critical value or values. Alpha is equal to 0.05 and right-tailed test. 1 minus 0.05 is equal to 0.95. Using the z table, z is equal to 1.65. Therefore, the critical value is positive 1.65. For the third step, compute the test value. Our formula is z is equal to sample mean minus average mean over standard deviation over square root of sample population. To substitute, 306.2 minus 305 over square root of 3.57 over square root of 55. Our test value is 4.71. For the fourth step, make the decision. The decision is reject the null hypothesis, since the 4.71 is greater than 1.65. As you can see in the illustration below, the test value is greater than the critical value. For the fifth step, summarize the result. There is enough evidence to support the claim that the average depth of the Hudson Bay has increased. It may increase due to warmer temperature or rainfall. For the second problem, ages of U.S. senators. The mean age of senators in the 109th Congress was 60.35 years. A random sample of 40 senators from various state senates had an average age of 55.4 years, and the population standard deviation is 6.5 years. At alpha is equal to 0.05, is there sufficient evidence that state senators are on average younger than the senators in Washington? To perform the hypothesis testing, the first step is state the hypothesis and identify the claim. In null hypothesis, mu is equal to 60.35, and in alternative hypothesis, mu is less than 60.35. For the second step, find the critical value or values. Alpha is equal to 0.05 and left-tailed test. 1 minus 0.05 is equal to 0.95. Using the z table, z is equal to negative 1.65. Therefore, the critical value is negative 1.65.
For the third step, compute the test value. The formula is z is equal to sample mean minus average mean over standard deviation over square root of n. To substitute, 55.4 minus 60.35 over 6.5 over square root of 40 is equal to negative 4.82. So the test value is negative 0.82.
Fourth step, make the decision. The decision is reject the null hypothesis, since the negative 4.82 is less than 1.65. As you can see in the illustration below, the test value is less than the critical value. For the last step, summarize the results. There is sufficient evidence to conclude that the state senators are younger than the senators of Washington. We are now in the third problem. Peanut production in Virginia. The average production of peanuts in Virginia is 3,000 pounds per acre. A new plant food has been developed and is tested on 60 individual plots of land. The mean yield with new plant food is 3,120 pounds of peanuts per acre, and the population standard deviation is 578 pounds. At alpha is equal to 0.05, can you conclude that the average production has increased? So now let's perform the hypothesis testing. The first step is state the hypothesis and identify the claim. In null hypothesis, mu is equal to 3,120, and in alternative hypothesis, mu is greater than 3,120. For the second step, find the critical value or values. Alpha is equal to 0.05 and write tailed test. 1 minus 0.05 is equal to 0.95. Using the z table, z is equal to 1.65. Therefore, the critical value is positive 1.65. For the third step, compute the test value. The formula is z is equal to sample mean minus average mean over standard deviation over square root of sample population. To substitute, 3,120 minus 3,000 over 578 over square root of 60. The test value is 1.61. For the fourth step, make the decision. The decision is accept the null hypothesis, since 1.61 is less than 1.65. As you can see the illustration below, the test value is less than the critical value. For the last step, summarize the results. There is not enough evidence to support the claim that the average of production has increased. For page 36, for the first problem, cell phone call lengths. The average local cell phone call length was reported to be 2.27 minutes. A random sample of 20 phone calls showed an average of 2.98 minutes in length with a standard deviation of 0.98 minutes. At alpha is equal to 0.05, can it be concluded that the average differs from the population average? To perform the hypothesis testing, the first step is state the hypothesis and identify the claim. In null hypothesis, mu is equal to 2.27. In alternative hypothesis, mu is not equal to 2.27. For the second step, find the critical value or values. Alpha is equal to 0.05 and two-tailed test. Using the table F, df is equal to 19. Therefore, the critical values are positive and negative 2.093. For the third step, compute the test value. The formula is sample mean minus average mean over standard deviation over square root of sample population. To substitute, 2.98 minus 2.27 over 0.98 over square root of 20. The test value is 3.24. For the fourth step, make a decision. The decision is to reject the null hypothesis, since 3.24 is greater than 2.93. As you can see the illustration below, the test value is greater than the critical value. For the last step, summarize the result. There is enough evidence to support the claim that the average differs from 2.27. The second problem is commute time to work. A survey of 15 large U.S. cities finds that the average commute time one way is 25.4 minutes. A Chamber of Commerce executive feels that the commute in his city is less and wants to publicize this. He randomly 25 commuters and finds the average is 22.1 minutes, with a standard deviation of 5.2 minutes. At alpha is equal to 0.10, is he correct? To perform the hypothesis testing, The first step is to state the hypothesis and identify the claim. In null hypothesis, mu is equal to 25.4. In alternative hypothesis, mu is less than 25.4. The second step is find the critical value or values. Alpha is equal to 0.10 and left-tailed test. Using the table F, df is equal to 24. Therefore, the critical value is negative 1.318. The third step is compute the test value. The formula is T is equal to sample mean minus average mean over standard deviation over square root of sample population. To substitute, 22.1 minus 25.4 over 5.3 over square root of 25. The test value is negative 3.11. The fourth step is make a decision. The decision is reject the null hypothesis, since negative 3.11 is less than negative 1.38. As you can see the illustration below, the test value is less than the critical value. For the last step, summarize the result. There is enough evidence to support the claim that the average commuting time is less than 25.4 minutes. The last problem for page 36. Internet visits. A U.S. web usage snapshot indicated a monthly average of 36 internet visits per user from home. A random sample of 24 internet users yielded a sample mean of 42.1 visits, with a standard deviation of 5.3. At the 0.01 level of significance, can it be concluded that this differs from the national average? To perform the hypothesis testing, the first step is to state the hypothesis and identify the claim. In null hypothesis, mu is equal to 36. In alternative hypothesis, mu is not equal to 36. The second step is find the critical value or values. Alpha is equal to 0.01 and two-tailed test. Using the table F, df is equal to 23. Therefore, the critical values are positive and negative 2.807. The third step is compute the test value. The formula is T is equal to sample mean minus average mean over standard deviation over square root of sample population. To substitute, 42.1 minus 36 over 5.3 over square root of 24. The test value is 5.638. Fourth step, make a decision. The decision is reject the null hypothesis, since 5.638 is greater than 2.807. As you can see the illustration below, the test value is greater than the critical value. The last step is summarize the result. There is enough evidence to support the claim that it differs from the national average and the mean is not 36 visits. For page 29, the problem is he recently received a job with a company that manufactures an automobile anti-theft device. To conduct an advertising campaign for the product, you need to make a claim about the number of automobile thefts per year. Since the population of various cities in the United States varies, you decided to use rates per 10,000 people. The rates are based on the number of people living in the cities. Your boss said that last year the theft rate per 10,000 people was 44 vehicles. You want to see if it has changed. The following are rates per 10,000 people for 36 randomly selected locations in the United States. Questions are, first, what hypothesis would you use? In null hypothesis, mu is equal to 44. In alternative hypothesis, mu is not equal to 44. The second question is the sample considered small or large? For us, we considered it as large. The third question is, What assumption must be met before the hypothesis test can be conducted? It must be normally distributed. The fourth question is, which probability distribution would you use? The probability distribution we use is z-test. The fifth question is, would you select a one or two-tailed test? Why? We would select two-tailed test since based on the problem we are comparing two events, if one of them will change. The next question is, which critical value would you use? At alpha is equal to 0.05, be significant level, critical values are positive and negative 1.96. Next is conduct a hypothesis test. Use standard deviation is equal to 30.3. Z is equal to 55.97 minus 44 over 30.3 over square root of 36 is equal to 2.37. The next question is, what is your decision? 2.37 is greater than 1.96, or p-value is equal to 0.068, less than 0.05. The decision is reject the null hypothesis. The next question is, what is your conclusion? There is enough evidence to conclude that the car theft rate has changed. The next question is, write a brief statement summarizing your conclusion. The car theft rate has changed or increased. For the last question, if you live in a city whose population was about 50,000, how many automobile thefts would you expect to occur? If we were live in a city whose population is 50,000 and the car theft rate is 44, I will expect that there are 220 car theft in 50,000 people that people have. For page 37, the problem is how much nicotine is those cigarettes. A tobacco company claims that its best-selling cigarettes contain at most 40 mg of nicotine. This claim is tested at the 1% level of significance by using the results of 15 randomly selected cigarettes. The mean is 42.6 mg and the standard deviation is 3.7 mg. Evidence suggests that nicotine is normally distributed. Information from a computer output of the hypothesis test is listed. Sample mean is equal to 42.6. Sample standard deviation is equal to 3.7. Sample size is equal to 15. Degree of freedom is equal to 14. P-value is equal to 0.008. The significance level is equal to 0.01. Test statistic T is equal to 2.72155. The critical value T is equal to 2.62610. Questions are, what are the degrees of freedom? The degrees of freedom is 14, since the sample size is 15. Then subtract it to 1. 15 minus 1 is equal to 14. The second question is this z-test or t-test? Since this is one-sided, we have to use t-test. The third question is this a comparison of one or more samples? Only one sample, which is the best-selling cigarettes, that contains at most 40 mg of nicotine. The fourth question is this a right-tailed, left-tailed, or two-tailed test? This test is a right-tailed test, since the interest is increased only. The fifth question is, by comparing the test statistic to the critical value, what would you conclude? Reject the null hypothesis, since the test statistic is greater than the critical value such that 2.72 is greater than 2.63. Next question is there a conflict in this output? Explain. There is no conflict because it shows correctness along the process. For the last question, What has been proved in this study? There is no enough evidence to support the claim by the tobacco company that their cigarettes contains at most 40 mg nicotine. Page 44. The problem is, for a sports radio talk show, you are tasked to research the question whether more home runs are hit by players in the National League or by players in the American League. You decide to use the home run leaders from each league for a 40-year period as your data. The numbers are shown. The data is shown below. The questions are, first, define population. The average population of National League for home run leader is 44.75, while the average population of American League for home run leader is 42.88. The second question is, what kind of sample was used? The kind of sample was used is cluster. Third question is, do you feel that is representative? For us, it is no. It is not representative. The fourth question is, what is your hypothesis? In null hypothesis, mu sub 1 is equal to mu sub 2. In alternative hypothesis, mu sub 1 is not equal to mu sub 2. The fifth question is, what is the significance level we'll use? The significance level we will use is 0.05. The sixth question is, what statistical test will you use? The statistical test we will use is z-test. The next question is, what are the test results? First, we will compute to get the test result using this formula. To substitute, open parenthesis 44.75 minus 42.88 close parenthesis minus open parenthesis 0 close parenthesis over square root of 88.8 squared over 40 plus 7.8 squared over 40 is equal to 1.01. So our test result is 1.01. The next question is, what is your decision? The decision is fail to reject the null hypothesis at alpha is equal to 0.05. The next question is, what is your conclusion? There is no sufficient evidence to conclude that there is no difference in the number of home runs hit by National League and American League. The next question is, do you feel that using the data given reality answers the original question asked? For us, not at all. The last question is, what other data might be used to answer the questions? Maybe the other data that can be used to answer this question is to have another random sample to each league. That's all for Group E. Thank you.